Hello, everyone. Today, we are going to start learning about AI. In case if you are new to my sessions, you can always know about me by going to my LinkedIn profile. So, this is a rough agenda for today. What is AI, key terms, and hierarchies? We will briefly look into what Agentic AI is, but we will have a dedicated session on Agentic AI. Then we will quickly look into responsible AI and the kinds of work AI ML engineers do. How many of you are afraid about AI? When I started talking about AI, my daughter asked me whether AI is going to attack us like we see in movies. And my response to her was, if somebody is going for a war and they don't know anything about martial arts or anything about the way they are going to fight, definitely they will fail, right? But if you know how to fight, if you know the other player well, then you can win. That is why instead of fearing about AI, just embrace it. Just try to learn it. People say AI makes people productive, but why we are not seeing a lot of new products in the market because of this productivity? And the answer, according to me, is just because AI makes things more easy or it makes you more productive, you doesn't have to build projects that do not have customers. Because of that, companies definitely will be firing some people because previously those work that needed 10 people may now need lesser number of people. So rather than increasing the products that people do not need, companies are going to leave some people out. So what you can do is learn about AI and be prepared. So what is this thing called AI or artificial intelligence? In very simple terms, AI is making machines behave like humans. It can predict outcomes and recognize patterns based on historic data. So when you give lot of historical data, then you can predict, okay, based on the historical data and based on the patterns I have derived, okay, this is going to happen. It can also recognize abnormal events and help us make decisions. It can also interpret visual input. So like the computer vision area, right? So it can detect, okay, something is wrong and then notify. You have self-driving cars. AI can understand language and engage in conversations. The most common use case most of you are aware about today, right? Asking ChatGPT or similar tools and then getting answers. And you can also extract information from sources to gain knowledge, maybe your receipts or bills or something. AI was there for some time, but the recent AI boom is mostly due to LLMs and GenAI, right? Is GenAI a subset of LLM, or what are these terms like LLMs and GenAI? How are they related to the broader AI term? So when I say AI, the bigger umbrella of AI just make sure the systems behave like humans. The next category within AI is ML or machine learning. You teach machines to learn from data. So rather than telling them everything on your own to work like humans, you let them learn on their own. Like kids learn on their own, right? Many things. Until they go to school, nobody is going to sit and teach most of the common things, right? They see and they learn. So similarly, machines can see and learn. The next category is deep learning. So deep learning is a type of machine learning using layered neural networks. It is inspired by our brain. And then comes generative AI. So AI has been there for quite a very long time. But all of these AI things became popular like we see today only in last few years. Why? It is mostly because of GenAI and related tools such as ChatGPT. You may hear about these terms such as LLMs or large language model. So they are deep learning models trained on massive amounts of text. So GenAI uses LLMs to generate text. And it also uses other models such as diffusion models and all to generate other types of data like images. Even Apple's Siri answering your questions can be considered as AI. And when you say ML, you show a system thousands of cat and dog images. It learns how to tell them apart, and then you provide an image, and the system will tell you whether it is a cat or a dog. Deep learning that powers AI across NLP, which is natural language processing, chatbots, translators, and computer vision, like the face and object detection, speech recognition, like the voice assistants, generative AI, generating text, images, music, video, and even autonomous systems like self driving cars, robots. So, all of these things are powered by deep learning. Popular GenAI tools include ChatGPT, DALI, Music LM, Runway ML, and some of the popular LLMs like GPT from OpenAI, Bird from Google, Cloud A from Anthropic, Gemini from Google, Grok from XAI. So deep learning is a type of machine learning that uses layers of neurons within a neural network. So what are neurons? Neural networks are systems of interconnected nodes like neurons inspired by our human brain that process information and recognize patterns. Deep learning, which is a type of machine learning, uses this neural network and neurons to automatically learn very complex patterns from a vast amount of data, enabling tasks like image recognition, speech understanding, and natural language processing. And each of these neurons takes input, gives important to it using weights, and applies a simple rule to decide what to pass on and sends the result to the next layer. It is multi-layered, right? So this training part and all we will see in future sessions. Large language models such as GPT-4, Cloud A, or Gemini are transformer-based deep learning models trained on massive text datasets and power popular generative AI products such as ChatGPT, Cloud A, and Google Gemini Chat, etc. Model, the AI brain that learns patterns from data and makes decisions or predictions, which is the result of training. What is a training? Training a model is basically teaching that model with the data so it learns patterns. It's iterative, and after each round, we validate to tune it. After the whole training process end, we test it on unseen data. When we look into ML in detail, we will see how these training actually work. And then we have inference. It is using a trained model to analyze new data and make predictions or generate results, like answering a question or classifying an image. So basically, using that model. As many people are afraid, and there are reasons to be afraid. Many companies, many governments ask you to follow responsible AI principles. Basically, AI should be fair, inclusive, secure, trustworthy for everyone. Agentic AI, which is an AI that doesn't just chat or answer questions, but can think, plan, and take action on its own, mostly making use of LLMs, like booking a flight ticket with little human intervention. Agentic AI also has a dedicated session coming up. A quick example of agentic AI, since it is very, very important in today's world. The characteristics of agentic AI, with the example of flight booking that we briefly talked about in the previous slide, right? First one is autonomy, which means it operates independently, not just passively responding. The agent searches for flights on its own once you give it the destination and date. Second, goal oriented. It works towards objectives, not just predictions. So its goal is to find and book the best flight that matches your preferences. So like price, timing, airline, and also it is iterative. It learns and adapts through cycles of reflection and feedback. If the first option is sold out or too expensive, it rechecks alternatives until it finds a good fit. And it is also environment aware. It interacts dynamically with real world or simulated environments. It pulls in real world data like current flight schedules, weather updates to make smarter choices. It can use tools, can call APIs, run code, or leverage external tools to solve problems. The agent, for example, connects to airline APIs, compares prices on booking platforms, and even make the payment. So this is just one example, right? You can think about some use case, and when you receive the link to the recording video, you can comment on it. We will discuss on those examples in our dedicated Agentic AI session, and we'll also have a hands-on discussion on Agentic AI. So to build Agentic AI, you have some frameworks also. So when you are working on any cloud provider, they will give you some portal platform where you can build them. And there are also pro code frameworks like LangGraph and all that you can use if you like coding. There are also no code platforms. So we will explore all popular pro code platforms, low code platforms, and even cloud options within our Agentic AI session. You may get this question, right? So all of these things I can just write if else condition and I can do. But the difference here from that just workflow is that here you are using a model. Model is the brain, right? So different models you can test out. Accuracy and other parameters are based on those. You can configure some parameters such as temperature, TOP, etc. So those things also we will explore more in our generative AI dedicated session. Responsible AI principles. First one is fairness. So what is the risk here? A bias can affect results. Example, a hiring AI favoring one gender. Transparency. What is the risk? Decisions may be unclear. So AI might take some decisions, and you are unclear why AI took the decision. For example, loan denial without explanation. It should not be just like randomly choosing an option, right? And then privacy and security. What's the risk? Data may be leaked or misused. Example, a voice assistant exposing private conversations. There are many who are afraid that the voice assistants like Alexa, Siri, or the Google Assistant, those assistants that are always waiting for our commands, how they use that data, and even a tool like ChatGPT, whatever information you provide to that ChatGPT, it can be used for their training, right? Make sure you understand those risks before you work with any AI tool. And accountability, what is the risk? No one takes responsibility. Example, a self-driving car causing an accident with unclear liability. And also reliability and safety. What is the risk here? AI may fail or cause harm. Example, a medical AI giving a wrong diagnosis. Finally, inclusiveness. Some groups may be left out. Example, speech AI struggling with certain accents. So you may think, okay, it is AI, but how can AI make these mistakes, right? It could be also related to how it is trained. So if it is trained primarily using one gender, or if it is trained primarily using one race, so those can create issues later during the inference, right? The kinds of work AI ML engineers do, sometimes you'll be developing ML models. So ML engineers are building and training new ML or AI models from scratch. Example, a researcher at OpenAI designing a new LLM, or an engineer at Communities Canada developing a recommendation engine. One set of people develop models, but not everybody will be working in developing models in today's world, right? So second set of people will be using those models. And when you use those models, you can simply use that without any modification. For example, you have a AI agent, and within that AI agent, you have to use some model, and you use some model from OpenAI or some other company, and then use it without any modification. So that is one way of using it. And another way is adapting that model to your business use case. So you can take a model, a pre-trained model, you can provide it with additional training data. So that is fine tuning. But the problem is that not all models will allow you to fine tune. You can use another approach called RAG, which is retrieval augmented generation. So how many of you have heard about this term called prompt engineering? It is all about building good prompts. Prompts are what you tell the model. You type something, okay, ChatGPT, this is the context, okay, do that, do this is what I want. I don't want this kind of output, I want that kind of output. So, how accurate is your prompt? The response will be also that much accurate. For example, if you are asking it to generate some text, you cannot expect it to always give you correct answers. Sometimes it will give answers and it may be a wrong answer. That is called hallucination. But if you give some data, so if I have some data, sometimes I ask format this thing into something that is presentable for X system. So it will format it. So I have given some information and asked it to format. Consider it as option 1, and I just asked it to generate. Consider it as option 2. Which of these do you think will give you the most accurate document or formatted text? Option 1 or option 2? Option 1 is me giving ChatGPT some text and then ask it to format according to my need. Option 2 is asking it to generate. It's always when ChatGPT or any such tool has more information, right? That is the idea of RAG. Your organization may have a lot of documents available. You are asking ChatGPT or any tool a question. The system sits between you and the model that will search another database, usually a vector database, where information about your other documents are present. Along with that information that it receives from the other system, it will do the query against the model. That is called as RAG. So you make a query, you do not change the model, but you just change the prompt with additional more accurate data, maybe from your organization data. Either you change the model with additional data, that is fine tuning, or you change the prompt with additional data, that is RAG or retrieval augmented generation. The first set of engineers develop models, second set of engineers use models, and the third set of engineers use services that internally use models. When you go to Azure Cloud or AWS Cloud, you will have options to generate models, train models, and all. And you will also have option to fine tune and use RAG. And there will be also some managed services where you do not have to choose a model. You just trust that model. For example, in Azure, computer vision, document intelligence, and many services. So those services, we don't care what model. We can look into the documentation and understand what models are being used, but we don't have to select those models. We just use that service for our business use case. So that is also one level of using AI, right? The fourth one is agentic AI. So AI engineers are creating AI systems that can reason, plan, and act using models plus tools. Example, a customer support agent that not only answers questions but also research passwords, tracks orders, and processes refunds. So the traditional customer service, what they do, they will talk to you and they will do some operations for you. Otherwise, you talk to a bot and the bot will try to convince you with some answers. And finally, when we don't get the answers or when the bot cannot actually do the changes in the system, it will redirect you to some human. Okay, how many of you have got irritated with those bots in the past? So almost everybody here, right? So that is something that you can change with good AI agents. So if you look into any company these days, most of them will be saying AI powered or we have a AI agent. They will have something related to agentic AI. key stakeholders in the ML pipeline. ML pipeline involves data preparation, model training, and model consumption. As a ML engineer, you work with all the other stakeholders. So your focus is on ML training plus building business ready models. But you cannot do it without the help of other stakeholders, right? And you also need a data engineering team. So data engineering team uses various tools to collect the data and prepare the data as you need it and will give to you. So they are in charge of data preparation. That is their focus. And you also have a DevOps or ML ops team. So they will optimize ML training pipeline. So DevOps, one of the core principles of DevOps is to automate or build pipelines, right? And here you will be optimizing ML training pipeline. And their focus is on model training, speed and reliability. You also have a business team. They evaluates the model with metrics, confirms readiness for business use, etc. And their focus is model consumption and monitoring. So do not think one person is going to do all of these things, right? All of these things are really important. So you don't have to learn it all. But in today's world, many people try to learn as much as possible from all of these things because with the help of GenAI and all, you can be more productive. As long as you know things, you can use these tools to become more productive. But if you do not know the concepts, then using these tools can be dangerous also. Okay, so learn the concepts, then use tools to become more productive. But do not try to use these tools without knowing the concepts, just thinking I can be productive just by using these tools because you cannot trust the answers you get from these GenAI tools. So this was just tip of the iceberg. There are a lot of things to learn from generative AI. I have included a few links for you to start reading immediately after this session. So there is a question: do we have separate hands-on on RAG? Yes, when we discuss on both Azure as well as AWS cloud, that is the current plan, and maybe in future GCP. So when we look into any particular cloud, we will see hands-on for RAG also. That will be mostly part of the Agentic AI on cloud discussion. So, and if you have any doubts, just ask me. You can just go to codingarchitect.ca/contact to get my current phone number or WhatsApp number and also LinkedIn profile. So you can text me or WhatsApp me or you can DM me on LinkedIn. My blogs, AI nodes are part of codingarchitect.ai. Cloud nodes are part of cloudrix.com. And dev and security nodes are part of secdops.com. Stay connected. Go to codingarchitect.ca/contact and send me a text or a WhatsApp message and say hi. Bye bye for now and see you all in next class.